Thanks, Travis. I'm going to talk briefly about the models that worked best for us, the leaderboard on driven data, and then wrap up the talk with a few conclusions. As Travis mentioned, the vast majority of our time was spent learning how to handle a data set this large, feature creation, and exploratory data analysis. But we did manage to try out three types of models. We built XGBoost models, ridge regression models, and lasso models. XGBoost models were better at predicting power consumption than the ridge regression or the lasso models. So that's what we're going to focus on from here. So recall we had decided to fit models to each meter separately. Here are the XGBoost predictions for two of the meters. You can see that the models work pretty well actually for predicting power consumption, as there's a very linear correlation and basically a slope equal to 1 for each of these meters. So the models worked pretty well. Now what variables did they use? Well, these are the variable importance plots for these two XGBoost models. What stands out is basically these are all date-time related. Now at first I was a bit concerned that ambient temperature wasn't a part of the model, but after thinking about it, ambient temperature is probably baked pretty heavily into the date-time variables, meaning you can probably get a pretty good handle on ambient temperature just by knowing the time of day and what particular part of the year it happens to be. Moving on, this is the final meter. Again, the relationship between actual and predicted consumption values is linear with a slope of 1. And again, the most important variables are time and date variables. Now, before we wrap up, I want to talk about how this competition is scored. Your leaderboard position is based on this WPR number. This is calculated using the number of true positives, false negatives, and false positives. Now, if you venture over to the leaderboard on driven data, you'll see that the top positions on the board have scores of 0.8. Now, how did they get this? Well, it's pretty clear from the calculation that if you just pick one obvious anomaly and label the rest of the values as normal, you won't have any false positives. You will have many false negatives, but those aren't punished as heavily by this scoring metric. So, selecting one anomaly gives you a WPR of 0.8. So you can get a really high score here by not actually building good models, but just labeling an obvious outlier as the only anomaly. Another thing, when you just label every single record as an anomaly, you are already in roughly the top quarter of participants. Now, obviously, you don't have to actually make good predictions to do well on this leaderboard. And to be honest, it's a little disappointing because we don't really know where we stand here compared to everyone else. So, in closing, this problem had an enormous data set. Now, if we had more time, we would have set up some sort of a computing cluster so that we could have actually analyzed all 43 million rows. But we just didn't have the time really to figure out, how to do that. The size of the data set made this problem really tricky. So another thing that was tricky about the problem too was that the anomalies were not identified in training data, meaning it was up to us to actually define what an anomaly was and then predict when it occurred. So while it was difficult to identify anomalies, we ended up really focusing on how can we accurately predict power consumption. And we had the best predictions with XGBoost models. Lastly, we used those XGBoost models to make submissions to the competition, but there were a lot of quote unquote hacks that could be used to boost your ranking without actually making good predictions. This was pretty disappointing. All in all, we didn't really enjoy this project that much because of how it was put together on driven data. We probably could have recognized that from the onset, but I think at least myself personally was swayed by the fact that I'm kind of passionate about energy, and just overlooked these flaws in the beginning because of that. Oh well, live and learn, right? Anyway, thanks for listening to our presentation. It was a pleasure learning from everyone this quarter. Take care.